Hi, we are going to talk about solving advanced three-part inequalities. Those are the ones that require more work. So let's start with this one. This one's a little bit easier. So what we have here is there's x only in the middle part, so we can treat it the same way we do the other ones. We're going to start by subtracting 1. That's going to give us 6 greater than or equal to negative 2x greater than negative 4. So what we're going to need to do now is divide everything by negative 2, and because we're dividing by a negative quantity, we're going to have to flip the signs. So when you divide by negative 2, it's very important that these two signs are going to flip. And that's going to give us negative 3 less than or equal to x less than 2. Okay, and that's a pretty standard one. So what we do here is we're gonna be restricted between negative 3, where we're gonna have a closed circle, positive 2, where it's gonna be open, and we are going to shade the part between them to represent our solution. And using interval notation, this can be represented as bracket negative 3 to parentheses. This problem's done. Let's take a look at the next one. So here's the problem that you're going to see from now on. This inequality here contains x not only in the middle but also in one of the other parts. And unfortunately, the same approach that we used with the previous problem is not going to work. So the only way you can solve these inequalities is by breaking them up into two. So this is going to be equivalent to the following. X is less than 2x plus 3, and 2x plus 3 is less than or equal to 5. And then you solve each of these inequalities individually, and after that you can go ahead and see what's going to be the outcome. Now, this is a very important thing. This is always going to be AND for these types of inequalities. So we subtract 2x. It's probably a little bit easier. So negative x is less than 3, which is going to give us x is greater than negative 3. Remember to flip the sign because we're going to be dividing by negative 1. Here we're going to have 2x is less than or equal to 2, and x is less than 1. Less than or equal to 1, right? So we have x is greater than negative 3, but at the same time you want x to be less than 1, less than or equal to 1. So it's going to leave you with, so if you start at negative 3 and go this way, and then you're going to start at 1 and go the other way because of AND. This requires for them to overlap. So this is going to be our solution here. Open at negative 3, close at 1, and everything in between will be shaded. This is the part that is going to give you this solution. And the interval notation will give you, it's very similar to what we had in the previous problem, from negative 3 with parentheses to 1 with a bracket. Okay, moving on. Same problem. Now we actually have x everywhere. We are going to do the same thing. So we are going to split them up. X plus 1 is less than 2x minus 3. And please do not forget, these are always going to be connected by AND. 2x minus 3 is less than 3x. Alright, so we solve it. Let's start this one. It's going to be negative x is less than negative 4. Subtract 2x and then subtract 1, which is going to give you x is greater than 4. So this other inequality here, I would probably subtract 2x, so negative 3 is less than x, which means x is greater than negative 3. There is AND connecting these two inequalities. Sorry, that's positive 3. Okay? No, that was actually correct. Ignore that. My apologies. It is Correct, x is greater than negative 3. So they're going in the same direction. So x is greater than 4 and x is greater than negative 3. So 4 is here. Greater than 4 would be going to the right. Negative 3 is here, going also to the right. I want to remind you, with AND, you're required to have some sort of an overlap. So the overlap for these two inequalities will be from 4 and up. So our final solution here will be from 4 going to the open at 4 going to the right. Because remember, both inequalities must be true when you have with and this inequality is going to be true, but if you're going to use certain values from these inequalities that are making that true, like for example negative 2, it's not going to work for that inequality. So this is the part that's going to be valid, and then this is going to be represented by this interval from 4 to infinity. Okay. Next problem. Similar. So again, we are going to split it into two inequalities. We're going to have x minus 4 less than 3x plus 2 and 3x plus 2 is less than 2x. So if we solve this, let me start here since I'm already at this one. 2 is less than negative x, so x is going to be less than negative 2. Right? And with this one, subtract 3x will give you negative 2x, and add 4 will give you equals 6. And this is going to give us x is greater than negative 3. Alright, so x is greater than negative 3 and x is less than negative 2. So these two inequalities will be true when you're going to be between negative 3 and 2 with both ends open. Okay, so here's negative 3, here is 2. And that's a kind of a short interval here, but that's what we got, that's what we got. So from negative 3 to negative 2, and we're done. Next problem. X minus 1 is less than or equal to x plus 3. And x plus 3 is less than 5 minus x. Okay, we're going to start with this one. When you subtract x on both sides, you're going to get negative 1 is less than or equal to 3, which is actually a true statement. So this alone would give you all real numbers as a solution, but we have another inequality which we're going to have to consider, so we'll have to do this also. 2x is less than 2 and x is less than 1. So even though this inequality here alone produces all real numbers as solutions, we're going to be restricted then by this condition here, and so x has to be less than 1. So here's 1, and less than 1 will be going to the left of that. And that's what it's going to look like. And with interval notation, we're going to go from negative infinity to 1 open. And I think we have one more problem left to do. This one. So, same approach, nothing changes. 3x plus 3 is less than x minus 1. And x minus 1 less than 2x. So here we're going to have 2x less than negative 4, which gives us x is less than negative 2. For the other 1, we are going to get negative 1 is less than x, which means x is greater than negative 1. And what's going to happen here, they're going in opposite directions away from each other. So there is no overlap if you're going to try to graph both inequalities on the same coordinate line. You're going to see that they do not overlap. An overlap is required, which means it's going to have no solution here. So you can't graph anything when it comes to graphing. And as far as interval notation, we're going to write no solution or an empty set. Okay, so this is how it's done, and I hope this helps.